All right, so now it's time to get into the actual subnetting, but before we do that, let's just have a look at our default subnet masks for class A, B, and C. All right, if you remember, our A, B, and C networks are defined by the first octet. All right, your first octet, 0 to 127, it's class A, 128 to 191, class B, 192 to 223 is class C. All right, we look at our default subnet masks. Class A default subnet mask is 255.0.0.0. All right, class B, 255.255.0.0, and class C, 255.255.255.0. And it's very important to actually see the binary representation of this, because this is what's going to help us with our subnetting. Now, if you look at the binary representation, you can see that the number of network bits increases as we go from class A to B to C. So in class A, all the first octet bits are ones, which gives us our 255. In class B, all right, our network bits are first and second octet, which give you 255.255.0.0. All right, and in class C, first, second, and third octet are all ones. All right, which gives us our 255.255.255.0. All right, so as you look at that, you can see that the number of network bits, the number of ones, increases as you go from class A to class B to class C. And the number of host bits, which are your zeros, right, decreases as you go from class A to class B to class C. All right, so what we're going to have a look at now is we're just going to start subnetting with class C. So let's just have a look at that quickly. All right, so class C default subnet mask is 255.255.255.0. All right, as you can see, all your network bits come first. All right, those are all your ones, followed by all your host bits, which are zeros. All right, now when we subnet, what we actually do is we start using up our host bits and we turn them into network bits. All right, and that allows us to increase the number of networks and reduce the number of hosts per network. All right, so a default class C network gives us a possible 256 hosts. Why 256? Because it's from 0 to 255. All right, remember, because you're starting at 0, all right, 0 to 255 gives us 256 unique possibilities in terms of the numbers we can have with 8 bits. All right, very important to understand that the first and the last bit, well, first and the last address rather, are important because they are reserved for special purposes. The first bit in any network identifies the network itself, and the last address in a network is the broadcast address for that network. So essentially, we can't assign that to any hosts. All right, so let's have a look at subnetting. Let's take an example and say we want 30 hosts per network. All right, so we want 30 hosts per network. All right, in order to work out the subnet mask for this, it's very simple. All we have to do is figure out how many bits we need to get to 30. And we look at our binary table at the top here. Right, it's very simple. All we need to do is figure out how many bits. That takes us to 1. 2 bits takes us to 3, 0 to 3. 3 bits takes us to 7. All right, still not enough. 4 bits takes us to 15. How am I getting these numbers? All you're doing is you're adding up these values. 8 plus 4, 12, plus 2 is 14, plus 1 is 15. Still not enough. I'm going to go one more bit. That takes us to 31. All right? Or in actual fact, 0 to 31, which accommodates our 30 hosts. Now that we know how many bits we need to get to 30 hosts, right, if you look up here, you'll see that all the network bits are 1s and all the host bits are 0. Because all the host bits are 0 and we're calculating for 30 hosts, right, these values over here should actually be zeros, right, because those are our host bits. We're calculating for 30 hosts, remember? So what we need to do is take those 5 bits that we said we needed, right, and specify them as host bits, which are 0. Right? That means whatever bits are left become network bits. Right? So our network bits are over here, 1, 2, 3. That's all that's left for network bits. Right? So if we look at the default subnet mask at the top there, what we're doing is we're actually getting rid of these 3 bits, right? And we're making them network bits. Right, so for our 30 hosts, we need 1, 2, 3 network bits. So we took away 3 host bits and we made them network bits. Right, we look back down here and we calculate what our subnet mask should be. Right, this value is 128 plus 64, which is 192, plus 32, which is 224. So this 0 over here actually becomes 224, right? And our subnet mask for 30 hosts becomes 255.255.255.224, right? And it's that simple. You've just finished your first subnetting, right? So for 30 hosts, we calculated what did we need to do? We needed to figure out how many bits we needed to get to 30, right? To do that, we added 1, 2, 3, 4, 5 bits, which took us to 31, right? That's our 0 to 31 here. We realized that these are 30 hosts, right? Host bits are zeros. So these 1s, right, should be 0 in the subnet mask, right? And whatever's left become your network bits, or 1s. Take those values, add them up. 128 plus 64 plus 32 gives you 224, and that's how you end up with your subnet mask of 255.255.255.224. All right, let's try one more example. All right, so in this example, we're going to look at what happens if we need 50 hosts per subnet. Right? Remember, procedure is exactly the same. Right? In order to get 50 hosts per subnet, we need to work out how many bits we need to get to 50. 1, 2, 3, 4, 5 we know takes us to 31, which is still not enough. Remember, how do I get 31? 16 plus 8 plus 4 plus 2 plus 1 gives you a 31. Not enough, so we actually need one more bit here, which takes us to 63, or 0 to 63, right? Remember from our discussion earlier, you can't use the first address and you can't use the last address. The first address is the network identifier. It identifies the network. The last address is the address that's used for broadcasting. So even though it's 0 to 63 with these 6 bits, right, you actually only end up with 1 to 62. Okay. Also remember that we are calculating 50 hosts, right? Because those are hosts and these are host bits, right? All of these should actually be zeros. 0, 0. Right? Those are host bits for our 50 hosts. Right? Whatever's left become your network bits. If I add up my network bits, or I add up my 1s here, right, I end up with 128 plus 64, which is 192. So if you look at the top here, should be 11000000. Right? Right there. Okay, so you end up with a subnet mask of 255.255.192. All right, pretty straightforward. So what I'm going to do now is I'm going to give you a few examples to work out, and then we'll see whether we all arrive at the same answer. All right, give these a try. All right, here are your three examples. These are the three you're going to try out. All right, you're going to work out first the subnet mask for 10 hosts per subnet, then for 15, and then for 100. All right, so just pause the video here, do your calculations, and we'll have a look at the answers when you're done. Okay, so you should have completed your answers by now. Let's have a look at A. We wanted 10 hosts per subnet. Remember, when we start off, all we have to do is work out how many bits we need to get to 10. So that gives us 1, that gives us 3, 2 plus 1, that gives us 7, 4 plus 2 plus 1, and that gives us 15. 8 plus 4 plus 2 plus 1, that gives us 15, or 0 to 15. Remember, as we said earlier, you can't use the first and the last, but that doesn't matter, it still accommodates our 10 hosts, right? These bits, remember, are host bits because we're calculating number of hosts per subnet, and whatever's left become your network bits. All right, so in this case, our network bits are 128 plus 64 plus 32 plus 16, which gives us 240. All right, so that's equal to 240, and our subnet mask becomes, we'll look at the top here, right? Alright, so this becomes 240. Alright, now subnet mask becomes 255.255.255.240. Alright, so what about 15 hosts? Now I'm going to leave this exactly as is for now, so that we can look at what 15 hosts is. Now, if you remember, what we said earlier was we needed 4 bits to get to 0 to 15. Right, but if you remember from earlier, we said that the first and the last address have special meaning. So the first one is the network identifier. So in this case, 0 is the network identifier, and 15 is the broadcast address for that subnet. Because of that, our 4 bits that we use here actually only give us 1 to 14. All right. And that's not enough for our 15 hosts. All right. Because of that, we've actually got to add 1 more bit. So if I just remove this over here and we have a look at this, all right, we need 1, 2, 3, 4. That takes us to 15. Not enough because remember, 0 and 15 cannot actually be used because 0 is the network identifier and 15 is the broadcast address. Because of that, we only have 14 possible host addresses if we use 4 bits. So we've got to go 1 more bit, which takes us to 31. All right, so that gives us 0 to 31. Remember, in actual fact, this actually only gives us 1 to 30. Why? Because the first address is used as the network identifier and the last address is used as the broadcast address for that subnet. All right. All of these are host bits because we're calculating 15 hosts, right? So they should actually be 0, right? And that means we've got 3 bits left for the network, right? So our subnet mask here becomes 128 plus 64, which is 192, plus 32, which is equal to 224. All right. So up here, we've got to just remove 1 bit. All right, and if we do that, we end up with 2, 2, 4. 1, 2, 3, right? And obviously there's an additional 0 there. All right, so our subnet mask here, if we need 15 hosts per subnet, is 255.255.255.224. All right, let's move on to our last one, 100 hosts. All right, so if we need 100 hosts, we're going to need a couple more bits here. So 1, 2, 3, 4, 5, 6, 7. Why 7? Because that takes us to 127. Right? If we left out this bit, we'd only get to 63. Right? Which isn't enough for our 100 hosts that we require. Right? As a result, we need that extra bit. Right? That gives us our 100 hosts. Remember, that takes us from 0 to 127. Right? Which accommodates our 100 hosts. Right, remember these are host bits, which means they are all 0. Right, and the last remaining bit becomes our network bit, which is 1. Easy enough to calculate, that's 128. Right, so up here, all you do is this becomes 1, right, and this becomes 128. Right, so our subnet mask becomes 255.255.255.128, and it's that simple. All right, what I suggest you guys do is just do a little bit of practice on this, right? And we'll have a look at a few other examples in the next video.